the square root of 1. Can't have that. To find, let's write this. To find the roots of complex number z. So these are the steps we should follow. First, write your z in polar form. Write your z in polar form, which is the z absolute value, CIS, blah blah blah. Okay? Let me put it this way. Okay, that is z equals CIS, let's say R CIS theta, something like this. Okay. Second, the roots. So the nth root of z, something like this, or should I say kth root of z? Nth root is fine. Nth root of z will be the that will be z raised to power 1 over n, which is going to be your R CIS theta to power 1 over n. Yes? And that is going to be R to power n. Usually you might be saying, oh, we should have like say theta over n, isn't it? Yes? But according to what we are about to learn, what do we know about cosine and sine? This is graph of sine. What is this value? Pi? Yes? 2 pi. That would be 3 pi. This is 4 pi. Let me draw this graph of cosine. What is this? Anyone? That's pi over 2. 2 pi over 2, which is pi. So I just say 2 pi over 2, so it's easy. This is 3 pi over 2. This is 4 pi over 2, which is 2 pi. This is 5 pi over 2. This is 6 pi over 2, which is 3 pi. You could see that for every 2 pi, you are coming back to the same. Right? Let's check cosine. This is your 2 pi. Also, for every 2 pi, you are coming back to the same. So that is why we say cos theta plus 2 pi is the same as cos theta. And similarly, your sine theta plus 2 pi should actually give you sine theta. Okay? You know, they're probably arranging the class and making sure everybody. Can we check this with calculator quickly? Everybody. So write cosine. Quickly, everyone. I need everyone on the calculator. Cosine. Pick any angle of your choice. Make sure you are in radian if you are using pi. If you are going to use degree mode of your calculator, use 360 instead of 2 pi. Pick any angle of your choice plus 2 pi in either degree or radian equivalent. Have you done that? Check the value. Note the value, then check the cosine of that value only without adding 2 pi and see if they are the same. Are they? Do you get my point? So if you have decided to use 50, check cos 50, then check cos 50 plus 2 pi in the brackets. Okay? Then try the same with sine. Can you try the same with sine? You get the same thing. So basically, adding 2 pi to your value makes it the same. Basically, it doesn't change it. So that is why, rather than talking about cos theta here, we're going to be, actually maybe I should have written it that way. This is going to be the same as, this is actually the same as r cis theta plus 2 pi, basically. Okay, maybe not. It's alright. I'm trying to see the bit. Okay, we have theta to power 1 over n. Okay, so this is r 1 over n cis theta plus. Remember, 2 pi. Does it work with 4 pi? Does it work with 6 pi? It's a periodic function. Okay, so basically it's 2k pi. Basically, okay, everything to power 1 over n. Do you all agree that this is the same as this? Do we all agree? Okay. So now if you apply the property that we all know, we get our CIS theta plus 2k pi divided by n. Now in this case, because you are, according to this fundamental theorem, there should be n values. You start from when k is equal to 0 up to when k is equal to n minus 1. So you have all your n values. Does it make sense? When k is equal to 0 up to when k is equal to n minus 1. So there are n of those values. So square root of z. So this is what we need. Even when we talk about the nth root of unity, we'll be using the same thing actually. Nakita, you won't be here tomorrow. The only thing is that for the nth root of unity, unity means 1. For the nth root of unity, this r is definitely 1. So you might be seeing in the video that we only consider CIS this one alone, without that, yes. And also, in that case, for 1, we already know what our arguments will be. Yes? So for 1, we know what the argument, so you might be seeing it slightly different. But this is generalization. For z to be either be real or complex or anything. Okay? So we're going to apply this now quickly. Do we have more time? Yes. We're going to apply this now quickly and start with that simple question that I was talking about. I'll start with a real number 1, and we'll start with something we know. Let's solve the equation z squared is equal to 1. Okay? By this, it means we want to solve z is equal to square root of 1. Right? Now this we already know. We know the answers are what? Talk to me, everybody. The answers are positive and negative 1. Please, let's speak up. We know they are 1. Let's see what happens in this case. So, what you need to do is change this 1 under the square root. Of course, maybe I write it properly as 1 to power half. Okay? Change this 1 into the polar form. What is the absolute value of 1? Absolute value of 1 is just 1. What is the argument of 1? 0. The complex number is here. You can actually pick that from your Gann diagram. 1 is here. It hasn't moved yet. Okay? So the theta is equal to 0 in this case. Okay? So which means by this root of complex number, the square root of, let's say from square root of z, nth root of z I mean, is equals r to power 1 over n CIS theta plus 2k pi divided by n. In this case I have 1, so the square root of 1 is actually, of course remember, your k will be from 0, 1, 2, up to n minus 1. In this case it will be 1 to power 1 over 2, yes? Actually because r is 1, we don't actually need to do that. So it's going to be 1 times CIS, so allow me to just write CIS. Do you agree? Then this is 0 by default. Then this is going to be 2k pi over 2 over n, sorry. Yeah, over 2 this time around. Because n is equal to 2. Okay? And that gives what? CIS what? Talk to me. K pi. So when k will run from 0 to 1, because there should be 2 values. Talk to me, please. Do you understand? K will run from 0 to 1. So when k is equal to 0, the square root of 1 will be what? CIS, yes? 0. So which means cos 0, no, 0 pi is 0. Cos 0 plus I sine 0. What is cos 0? 1. What is sine 0? So this is 1. That's one root. When k is equal to 1, square root of 1 will be cis pi. Yes? That is cos pi. Check that. I sine pi. What do you have as cos pi? What is sine pi? 0. So you have negative 1. So what are the roots now? 1 and negative 1, which we already know. Okay? This is just to check how this works, even in the cases that we can see clearly without actually going through this. Now, I'm going to extend it to the 6th root of 1. I know, 4th root I mean. And to see how interesting this is, we're going to do that in 2 ways. Solve z to power 4 equals 1. Solve c to power 4 equals 1. Everybody please look up. Everybody please look up now. Bradley, can you make sure you are here?
Yeah,
Good, okay. Everybody please look up. The first method, let's factorize and see what happens. Z to power 4 minus 1 equals 0. By factorization, what do I do? Yes, tell me what to write. Good. So what does that give us? Z squared plus 1, yes? This can still be factorized. Can this still be factorized? Yes? Come on, say it. You think no? Does anybody think this can be factorized? Of course, this is going to be another square, right? And this will end up giving z plus 1, z minus 1. Yes? The question is, can this be factorized?
Yeah.
Yes. Why?
1 is still negative 1 squared, so it can still be.
Okay, so 1 is negative 1.
Yeah.
The negative is not outside. It's actually inside the bracket.
Yeah.
So z squared plus minus 1 squared, is that what you're saying? But that's not difference of 2 squared. That is the sum of 2 squares. Difference of 2 squares says you must have z squared minus 1 squared. Not with a plus. Does that make sense? Think again. Can this be factorized? What do you mean? No? No calculator? Can this be factorized? Quickly. Plus 1 squared. But the thing is, we want to use difference of 2 squared, which says we must have it in this form. Can you put that in this form? Think deep. Think outside the box.
Oh, imaginary.
Thank you. With what you have said, can somebody now tell us what to do? Yes.
Z squared negative the I plus.
There's no plus.
No. Z squared minus I squared.
That's it.
And
Z
then
squared minus I squared.
Oh, never mind.
What is I squared? This on its own produces negative 1. And there's a negative here. So you are back to your plus 1. Okay? Good thinking. So now we can have our final to be z plus I, yes? Z minus I, z plus 1, z minus 1 equals 0. So what are the values of z? From here, negative I, plus from here, I, from here, negative 1, and from here. So there are 4 roots according to the fundamental theorem of algebra. Okay? But this is easily seen because you can see powers of 4, you can apply some basic property, you already know I squared is negative 1. The problem is when you have power 7, are you going to factorize it will be too complicated to think of. That's why we have these results. So what we did here was just to establish the result. All you have to do is remember this and apply it anytime. Okay? So we're now going to use, the second method is now to use that result. I put that here. So B, do we have this too? Because I want them compared side by side.
Yes.
Good. Why is my board moving? Apply the brake. Sleepy yet? Sleepy, sleepy. Why are you sleeping in class? Sleepy yet? So in your dreams, somebody told you about the complex factorization, I guess. Because you suddenly woke up and you tell us the right answer. What happened? Someone appeared to you in the dream, you had a nap, somebody told you, Mr. Daniel has a question. Wake up, wake up, wake up. The answer is this. Are you the new Ben Carson? Alright, so the second method, which is the main method we are trying to learn. Our Z is 1, so let's find, we already know the modulus and argument, so I'm just going to say from Z to power 4 equals 1, it implies that Z is the fourth root of 1, yes? So for 1, absolute value is 1, and the argument of 1 is 0. Uh-oh, what did I write? Okay, so now, for the root of 1 from, can I have everybody's attention? From the nth root of n, which is r to power 1 over n, CIS theta plus 2k pi divided by n, where your n is from 0 up to n minus 1. You just have to remember to state this, then apply it. Okay? You don't have to go through all the nonsense that I went through there. And I think they are in your IB formula booklet. But if you state it after each question, it becomes part of you. You don't have to memorize it too much. It becomes part of you once you state it over and over again. Okay? And it is not like two formula. Even if you do not know the nth root of unity, just start from here. When it is unity, this doesn't appear. Do you understand my point? So for the nth root of 1, in this case, the fourth root of 1 will be, this is gone, because r is equal to 1. CIS, theta is equal to 0, so it's not going to reflect anymore. It's going to be CIS what? 2k pi divided by what? 4, which you can write as CIS k pi divided by 2, where k is from 0 to what? What is n? 3. Each of these represent each root. There are 4 of them. So it's from 0 to 3. Does that make sense? And 3 is your n minus 1 because n is equal to 4. N is not 2. What we did here is to simplify. Does that make sense? So let's substitute. So the first one, so I'm just going to say, can everybody see? Okay? When k equals 0, the fourth root of 1 becomes what? CIS 0. Yes? Yes? And CIS 0 simply means cos 0 plus I sine 0. Cos 0 is 1. Yes? So we have 1 plus I times 0, which is just 1. Now when k is equal to 1, then the roots of 1 will be what? Actually, instead of calling it root of 1, we just say z equals, because we're actually solving for z. Z is the fourth root of 1. Does it make sense? So z will be CIS what? When k is equal to 1? Pi over 2. Some people are not saying anything. I need you to say something. So that will be cos pi over 2 plus I sine pi over 2. Cos 90 is 0, confirm? And sine 90 is 1. Yes? So when k is equal to 2, what do you get? Z equals CIS, yes? Pi. Yes? So which is equal to cos pi plus I sine pi. What is cos pi? Negative 1. Sine pi? 0. So I times 0, which is just negative 1. Yes? And finally, when k equals 3, what is z going to be? 3 pi over 2. So which is simply cos 3 pi over 2 plus I sine 3 pi over 2. What is cos 3 pi over 2? Cos 120 minus cos 60 minus half. Is that? No?
Plus 3 pi over 2 over here.
Pi is 180. 120 times 3, that's 360.
180.
No. 180 times
5.
90, that's 270. Is it?
Yeah. 270.
So what's the cost 270? Is that 0? Is it 0? Confirm. I don't trust Lillian.
Calculator 0.
Should be.
I don't trust Lillian. Okay, what about sign that?
Minus 1.
Minus 1. Okay, so we are good. So that's minus I. Can you see now? 1I minus 1 minus I. Just like that. But the only reason I did this is so we could, this is the official, let's say official way of doing it. But this is because we are able to test it using a basic method that we know, like a basic property, something that everybody knows from before now. Coupled with the fact that we know that I squared is -1. So this is just testing it. This is not a way of solving the problem. But so we can check the validity. And here also, it's easy to check. The square root of 1 is plus or minus 1. That's why I refer to that. Okay? So I'm going to pick a complex number that is not 1 or whatever. I'm going to apply this thing as well, quickly. Okay? Then the rest is for you to practice. Sometimes you might be asked to express your result in Argand diagram. Of course, to plot this in Argand diagram won't be a problem. Everybody knows where I is, where minus I is, and all that. Okay? Just check. That's fine. I think the next question, I would rather write it on the board and you practice it. Then if you are not able to, then we can do it as correction. Even though this looks easy because it's dealing with 1, what if you are not dealing with 1? What if you are dealing with 5 plus 7i, something like that? So just follow the steps, put it in that form, get your R, and simplify as far as possible. Sometimes, if this is 2, okay, just leave it as 2 raised to the power 1/3 or something. If this is 8, leave it as 8 raised to the power 1/3 and express the rest and put outside the bracket. Okay? So please take note of that. So I write some questions here for practice. And for the next 20-something minutes, let's see how much of this practice we can do. Again, keep your eye on the fundamental theorem of algebra. Every polynomial of degree n must have n roots. So if you are not done finding all the roots, you see, can somebody tell me from this formula of finding n roots, that particular variable that ensures the fundamental theorem of algebra is considered? Again, from the formula of finding n roots of any complex number, a particular variable ensures that we observe the fundamental theorem of algebra, that we consider it. What variable is that? Say that again. Are you sure? Are you sure? Which of the variables ensure that the fundamental theorem of algebra is considered? She said n, she said k. I'm not saying any of them is right or wrong. I need to be sure. Somebody who is certain to tell me, yeah, I'm sure. If you do not tell me I'm right now, I'm going to throw you out. Yes, sir.
Because it says n there.
Okay, because it says n, any other one?
K.
K, why? Okay, now is a vote. Like 1, 1, 2, 2.
Yeah, it's probably K.
K.
Why do you think it's K?
Where K
Yeah.
is equals to 0, 1, and
Exactly. K ensures that you consider n of them. Alright? K ensures that you have n of them, starting from the smallest value up to. So K is the loop. For those of you that do programming. So K is the loop, your counter in the loop. Yes?
to the people who does program.
No. It's just the word being called. It's called. K ensures the loop is repeated. K is the counter, in the loop. It's the counter in the loop.
Mr. Daniel.
Yes, sir. Of course.
Ethan,
It's still legal for now. Going to the bathroom is still a legal thing to do in my car.
Why When is it gonna be illegal?
Well, we have to ask the Macau House of Assembly. All right, so let's play with some sweet questions. Sweets,
My face is like
problems,
even after like moisturizer, it's still dry.
sweets problems.
Should I know this?
I don't know.
Like even
I
after
think so.
putting on like moisturizer, my face is so dry now.
So let's play with these sweet problems. Solve for Z. A. Z cubed equals negative 8I. Let's begin, please. Z cubed equals negative 27I. About 4 equals 16. Mr. Cheng, are you starting or you're trying to get Crystal's attention? Wait, not in that way. Come on.
Oh yeah, when are we gonna do the weekend classes?
Good question. Let's agree before Nakita leaves.
What?
Oh yeah, true. Nakita, Karen is
No, it's
done.
okay. We just need to care about what.
Oh yeah, we can talk about it on the WeChat group.
Karen's opinion doesn't matter.
What?
Oh.
No, it does.
Karen's gonna go along with it no matter what.
Yeah, I think she will actually.
Exactly.
Yeah, I think she will. We can have the discussion now and finalize when she's here, or check with her online later.
Exactly.
Wait, what are we talking about?
The weekend classes.
Oh.
The sweet weekend classes.
You gotta wake up now.
Oh no.
Later, make Kimberly join psychology. I'm going to watch anime. I can just like me watch
Come on. Let's do the work.